Hello. In this video I'm going to show you our quick start demo for influence maps and how it's made. The demo is pretty simple. I'm in a level and these balls will try to follow me wherever I go based on my influence map. The influence map can be viewed in the gameplay debugger by pressing the apostrophe key. So as you can see around me it's yellow, but far away they are blue. To create an influence map, what you need to do is basically create an actor of type WF influence map, which usually would mean that you simply create a blueprint and then inherit from WF influence map and then name it new map or whatever. I already had one, so let me delete this one. So this one was the map called players, and I didn't add anything to it, like no logic, nothing. These are the default values, but I changed them. Oops. I changed them in the level instead of in the content window. So if in the level, look at this. Basically, I named it players, moved it to 000, and set the width and height to 60. Influence maps, unlike volumes, do not have their center at their position, and instead they basically their 000 is their corner, where they are is their corner. So let me show you. When I put it in 000 here, then it would mean that it will have a width of 60 and then a height of 60 until here. So basically that's what their dimension is. And then here are the debug colors, which will be used in the debugger, both gameplay debugger and visual logger, because both will have that. In order to put an object's influence on the map, basically what you need to do is that to add a WF influencer agent component to it, and then it will ask you on what map you want to put your influence, which we say players, and then here you can give a template and on like how the shape of the influence should be, and a template is basically a radius and a curve, which I have here, an inverse linear curve. If I modify this, the shape will be modified. At the moment it's almost like a circle starting at my center, and then as it moves to the edge, basically the color becomes like looks like blue, so it's approaching 0. So if I look at it from the top, it's more obvious, but a better way to visualize would be to use visual logger, and as I move, this will change as well. Now if I select the frame and then look at the map, as you can see, where the player was, it's more yellow, and the shape is basically look like a circle, strong at the center, which is identified by that blue sphere, and then smoothly goes towards 0, and the rest is mostly like 0. As you can see also the numbers here, if you want to know exactly what value SL is, and it's not obvious from the color. You can like look at the numbers in the visual logger. And now using this, the other agent can search for where the player is. So I created a very simple follower agent. I derived this from, like, inherited from a default pawn, so I can move it, and I need an AI controller to move. But the more important thing is that in order to move this, I first get the player's map and then search on it for anything bigger than 0.2 in my 10-meter radius. And if the result was a successful search, which is indicated in this boolean, then I will use this position which the search found to move, basically to move there. And I could make this more complex, for example, not start another move if I have not arrived in the previous position. But this is a quick start guide, so I didn't want to make it more complex. But for example, if I want them to get closer to me, I can be like search for 0.7 instead of 0.2. And then now they should get much closer to me compared to the previous one. And also I can reduce the radius so I can get away from them. Now they search for their 10-meter radius. If I reduce the radius, then I can get away from them. So if I reduce the search radius to, let's say, 4 meters, then because this happens every 2 seconds, when I get close to these, then they will come to me. Okay. But because they do not move in that 2 seconds, I can essentially run away from them. So I can, at least I think so. Maybe I'm not right. Yes, I'm right. Now if I get close, they come to me. And if I want to move with them, I can move a bit more slowly, like a basically what it was called, shepherd does, to have my sheep around me. And then if some of them are left alone, I could add game mechanics on top so I can simply go back, like let some of them stay where they are and go back and bring those which aren't with me. This is totally unexpected. It just like came to my mind and I tested it. And if I want to, I can have other mechanics based on these, of course. So let's say I want them to detect me wherever I am and try to come to me like really close to me and put a radius at 60. So the whole map is 60. So wherever they are, they'll try to just jump at me, no matter where I am. Those which have a path, of course, those which don't cannot do the same. And I can try to get away from them, but good luck. See? Okay. Okay, I wanted to go up there so they cannot come to me. I will try, but there are some up there, so it not will not be like now these will try to now those because they do not have a path to me. They are just down there and I can kill them from up here. But these ones, okay, so I'll never be able to escape these. That would be fun. Interesting game mechanics can be made with this. So as you can see, but now if I want them to just be close by, but not too close, I would say instead of 0.8, would say 0.1. And I can even like duplicate them. So there are many, but they just try to surround me. Let's increase it to 0.5 so they are closer, but not too close. You can get the trial version of Influence Maps, by the way, from our website. You don't have to buy this, and then you can test for 2 minutes at each Pi session.